Now we will consider problems where we have to integrate integrals where the integral involves the term square root of x squared plus a squared. Now in this case, what should be the substitution? Now if you look at this is x squared plus a squared, and our motivation again comes from the trigonometric identity. Sine square theta plus cosine square theta is equal to 1. Okay. Now, nevertheless, we don't have this pattern where the constant and x is together. So we look at this, tan square theta plus 1 is equal to secant square theta, and this starts to look like our integral here. So, but we is not quite yet there. So multiplying by a squared, you have a squared times tan square theta plus a squared is equal to a squared times secant square theta. Now this really looks like this if we have x is equal to a times tan of theta. So that's the reason we have this as your substitution, x is equal to a times tan of theta, and where the interval is minus pi by 2 to pi by 2 to ensure that the function is 1 to 1. Open interval in this case because tan of pi by 2 doesn't exist. Okay, so if we have x is equal to a tan of theta, we get dx as a times secant square of theta. And our square root of x squared plus a squared becomes a times secant of theta. So let us solve a problem. Suppose the problem is to find out the integral of x squared plus 4. Okay, so in this case again we have a term square root of x squared plus 4, a constant. So this can be rewritten like this, where a is 2. So our substitution in this case is x is equal to 2 times tan of theta. Therefore dx is 2 times secant square of theta d theta, and square root of x squared plus 4 becomes 2 times secant of theta. Very well. So my integral becomes integral of dx, which is 2 times secant square theta d theta divided by 2 times secant theta, which is integral of secant theta d theta. Okay. Now this integral can be computed. Well, you can either remember what this integral is, or we can evaluate it right now. So I is integral of secant theta d theta. We multiply numerator and denominator by secant theta plus tan theta. Divide by secant theta plus tan of theta, and then you have something like this: secant square theta plus secant theta tan theta d theta divided by secant theta plus tan of theta. Now if we know, if you put u as secant theta plus tan theta, du is secant theta. What is the derivative of secant? Derivative of secant is secant theta times tan of theta, and the derivative of tan is secant square. Okay, and this is exactly what we have in the numerator of the integral. Therefore we get this integral as integral of du over u, and we know that this thing is natural log of absolute value of u plus c. But what is u? U is secant theta plus tan theta. So here we have this integral as natural log of absolute value of secant theta plus tan theta plus the constant of integration. But the problem is not yet finished, because the problem with the statement is in terms of x, right? And the answer should be also in terms of x, not theta. So we have to resubstitute back the secant theta and tan theta. So if x is equal to 2 times tan theta, so the triangle corresponding to this is x over 2 should be tan. So x over 2, okay, that makes it tan of theta as x over 2. And then you have x squared plus 4 because of the Pythagorean theorem. Okay, so what do we need? We need secant theta and tan theta. In this case, secant theta is 1 over cos, so it is square root of x squared plus 4 divided by 2, and tan of theta is x over 2. So the answer in terms of x is the integral I is equal to the natural log of absolute value of secant theta plus tan theta, which is x squared plus 4 square root over 2 plus x over 2 plus the constant of integration. So remember, don't stop your answer at this step. You have to resubstitute the trigonometric ratios in terms of x. Now we will discuss the integrals where you have a term that looks like square root of x squared minus a squared, and in this case also we have to go for trigonometric substitution. And so what is the motivation again for this part is there is a minus sign, so we have to use tan square theta plus 1 is equal to secant square theta, which comes from the sine square plus cosine is equal to 1. Here we don't see a minus sign, so we need a minus sign somewhere with x term which corresponds to some theta term as the positive term, and the constant which corresponds to 1 as a negative. So the only way you have it is tan square theta is equal to secant square theta minus 1. Okay, it's not yet there, so we have to multiply throughout by a squared. So you get a squared is equal to tan square theta is equal to a squared secant square theta minus a squared. Now this starts to look like our term here. And if you put a secant theta is equal to x, we get this thing as x squared minus a squared term, and the square root of that would be a times tan of theta, right? So if you put x is equal to a times secant of theta, the square root of x squared minus a squared, which is a squared secant theta minus a squared, becomes square root of a squared tan of theta. Now again, in this case you have to be careful that one must take the secant of theta from 0 to pi by 2 to make this function 1 to 1. Okay, so if you have this, what is dx? Dx is a times secant theta times tan theta d theta. And the triangle corresponding to this is this. X over a is secant. So cosine is a over x. A over x. And the other side, which is x squared minus a squared square root, becomes a times tan of theta. So this is the other side. X squared minus a squared. Okay, so this is the motivation about these problems. So let us solve a problem involving a term square root of x squared minus a squared. Okay, suppose we have to solve this problem where this is the integral of 1 over square root of x squared minus 4. So with our previous intuition we have x is equal to 4 times 2 times secant theta, and if you have this, then dx becomes 2 times secant theta tan theta d theta, and square root of x squared minus 4 becomes 4 times secant square minus 4, which is 2 times tan theta. Okay, so let us solve this problem. I equals integral dx, which is 2 times secant theta tan theta d theta divided by the square root term, which is 2 times tan of theta. Oh, so I get basically secant theta integral again. Okay, so if you solve this thing, we know we have just solved this as the natural log of absolute value of secant theta plus tan theta. So the answer here is natural log of absolute value of secant theta plus tan theta plus c. Okay, but we know that the answer has to be in terms of x and not theta, right? So in our triangle we have theta here, and x is equal to 2 times secant, that means cosine is 2 over x. So this satisfies this condition, and this remaining side is x squared minus 2. So in terms of this triangle, we have secant theta as 1 over cosine, so it is x over 2, and tan of theta is square root of x squared minus, this should be 4, x squared minus 4 over x. So substituting these things into this natural log term, we get the answer as the natural log of absolute value of x over 2 plus square root x squared minus 4 over x plus the constant of integration.